Hello friends, welcome to engineering tutorial. So we'll continue our discussion with Thevenin theorem application to dependent source circuits. This is the third question. So we have here a circuit involving a current dependent current source and two resistors. So here we have been asked to find the Thevenin equivalent circuit, that is to find VTH and RTH. Now an important thing to notice here is that in this circuit there is no independent source. There is no independent voltage source, no independent current source. So in these type of circuits in which there are no independent sources, independent sources, be it voltage, be it current. In circuits where there are no independent sources, Thevenin voltage is equal to 0 volt. Okay, no need to do any calculation, straight away VTH is equal to 0 volt because there are no independent sources there present in the circuit. So the only thing that is left here to calculate is RTH. Okay, so we have to find RTH. So as there are no independent sources, so nothing to deactivate, nothing to short circuit or open circuit, but we have to connect our own excitation voltage or current. So looking at this circuit, we can connect a 1 ampere current source. I have already discussed two methods of finding RTH, 1 volt and 1 ampere. So here we will be using this one current source connecting method. We have to find this terminal voltage V0. RTH will be V0 by 1 ampere here, and this is in terms of volts, and it would be in terms of ohms, whatever the unit is, kilo ohm. Now we will be using nodal analysis method to find out the value of V0. This is important. Once we have V0, we can determine RTH. So main objective is to find V0. So here let us connect the ground first, okay, for analysis, easier analysis. Here the terminal voltage is V0, it means here the node voltage also will be V0, here also the node voltage will be V0 because there are no resistors in between, so no voltage drop. So one nodal equation will be there. Okay, now let us say this is a outward going current, this is an incoming current, this is an outward going current. Another important thing, to establish the relationship of Ix in terms of the node voltage. Here Ix is flowing from ground to V0. So Ix will be written as ground potential, that is 0, minus the node potential, that is V0, by resistance involved, which is 2 ohm. This is the first relationship, this is the second relationship. Ix is 0 minus V0 by 2 or minus V0 by 2. So here let us write the nodal equations. All the outward going currents on one side, all the incoming currents on the other side. So here 1 ampere and Ix, they are flowing towards the node. 1 plus Ix, 1 ampere and Ix, all this is one node because the node potentials are the same, V0. 1 ampere plus Ix on one side, 2 Ix and this current, okay, this is V0 minus ground by resistance involved, which is 4. Okay, I have already made a video related to applications of nodal analysis, you can check it out. Now we will replace Ix with this. 1 Ix is minus V0 by 2 equal to 2 Ix, which is minus V0 by 2 plus V0 by 4. Okay, that implies bringing all the V0s in one side, it will be V0 by 4 plus V0 by 2 minus V0 is equal to 1. That implies, taking 4 as the LCM, V0 plus 2 V0 minus 4 V0 is equal to 1. That implies minus V0 is equal to 4. That implies V0 is equal to minus 4 volt. V0 is equal to minus 4 volt. This is the third important relationship. Now we have got V0 is equal to minus 4 volt. So RTH will simply be minus 4 volt by 1 ampere, which is equal to minus 4 ohm. Now many of you will be surprised that resistance is negative. How can resistance be negative? RTH is coming minus 4 ohm. Now we know that I've already discussed it in the basic concepts related to electrical circuits. Okay, we have got V0 equal to minus 4 volt and all of this. So let me erase this. Okay, let me write V0 is equal to minus 4 volt here. So we have already discussed that in the previous introductory videos related to electrical circuits, that when current flows through a resistor, the voltage polarity is always in this way. VR, current I, let's say this is R, VR is equal to IR. It means that this resistor, it is absorbing power. Resistors always absorb power. I've always said in all my videos. In this case, minus 4 ohm resistance, what it means is that the dependent source actually, that is supplying the power. Okay, the dependent source is supplying the power. It means that here what this is trying to say, that it is like this, minus plus. It can never happen. Okay, it can never happen. It means that the resistor is supplying power because current is flowing externally from plus to minus. It can never happen. Resistors can never supply power. They always absorb power. So it is because of this dependent source, the dependent source and the combination of resistors, they are combined in such a way that this resistance is coming minus 4 volt. But it is not possible. Resistors always absorb power, and the voltage drop equation is like this, plus IR. It is never minus IR. In this case it is minus IR. So here this is just for a mathematical equations and calculation purpose. This is for supply. Okay, supplying power. Here it is for absorbing power. So resistors always absorb power. So don't confuse with this negative resistance thing. It means that the dependent source is supplying the power. Okay, so this is the third equation, and the two important conclusions that we draw here is that in circuits in which there are no independent sources, be it voltage or current, the Thevenin voltage is 0 volt. In that case we have to only find the RTH. And about the negative resistance thing, resistors always absorb power. The voltage drop equation is like this, polarity is like this. This is for mathematical calculation purposes. Sometimes in questions you have to just understand it. This is for supply, circuit element supplying the power. Most of the times voltage sources, they have like this, current I like this. It means that the current, this voltage source, this is supplying power, the same thing as this, but resistors never supply power, they only absorb power. So this is correct. Okay, so I hope you like this video, and we'll discuss the next series of questions.